Welcome everybody to a demonstration of XLRISK. My name's David Vose, the director of Vose Software. I'm going to start with a very simple example, something that everybody can really understand. So here we have Excel, and you will see that there is another ribbon on top of the ribbon for XLSTAT. In Excel Optim, you also have the ribbon XLRISK. And here we have a number of different icons, and over the course of this demonstration, I will go through most of these icons. Now, there is a great deal of capability within XLRISK, so I don't intend to try and explain everything to you, but I want to give you a flavor of some of the power of what you can achieve with XLRISK. So, in this example here, I'm deciding to build a house. And I'm trying to figure out how much it's going to cost to build that house. So I've got a number of different items. First of all, I would have to purchase the land, and inevitably I'm going to have to pay some tax on the price of the land. I'll have to pay some legal fees, and then I'm going to have to start with my basic building of the house. I'm going to lay the foundations, construct the walls, etc., etc. Now, what we will typically do is we will come up with our best guess estimate. So here is in the center column, in column D here, I've got my best guess estimate in thousands of dollars, euros, whatever. All right, so my best guess is that the cost of the land I'm going to purchase will be, say, $110,000. But I also recognize that it could be as low as $105,000 and maybe as high as $130,000. You'll notice that the distance between the minimum and best guess and between the best guess and the maximum is not equal. And that's normal. It's quite consistent in almost any field that your uncertainties will have some asymmetry to them. If it's to do with cost, it's a rule of the world that all sorts of things can go wrong, and so the cost can get larger and larger, but not many things can go very right to make the cost go smaller. So we tend to have that around our best guess, which is our most likely estimate, we'll have values that could be a bit smaller, but, inevitably they could be quite a lot bigger. Now, what one might do in a traditional cost analysis is to come up with your estimates of each of these individual items and then add them up at the bottom. And that's what we've done here. You can see it's a sum of this column. And then we might go for a minimum. So here is a second column of the minimum amount we think we might have to spend. And then we can see that it could be as low as $370,000. And we do the same thing for the maximum, and it could be as high as $460,000. In other words, we feel that this is our best guess, 404, but the range is 370 to 460. The question is, how likely really is it that it could be as low as 370? How likely is it could be as high as 460? And if we were trying to budget for the construction of this house, what is a reasonable maximum amount that we should budget for? This is a very simple, very powerful use of risk analysis. And we have all the data here that we need. So let's start off. And what we're going to do is we're going to add uncertainty into this column F. How do we do that? Well, we go into the XLRISK ribbon and we select a probability distribution. So I'm going to click on the cell, F4, which is going to be the uncertainty in the cost of purchasing land. I click on Select Distribution, click on Select Distribution here. I'll explain a little bit about some of these other items a bit later. And a window opens, and it gives me a list of all the different probability distributions that are available in XLRISK, and there are many. It's fair to say that almost everybody will use a tenth of the distributions available in XLRISK, but those distributions will vary very widely from one person to another. If you're in engineering, you'll be using lifetime distributions. If you're in finance, you'll be using other types of distributions of return. But here we're going to be using subjective distributions because these are our guesses. They're not based on any data. So we'll click on the selection subjective and we get a subset of all of the distributions available to us. Now, when you know your distributions, and for most of us, we probably just need 10 or so, you will know which ones to pick. For now, I'm just going to tell you that a good distribution to pick here would be something called PERT. PERT is an abbreviation for Project Evaluation and Review Technique. It's an old name because it comes from a very old technique, but it's a very powerful distribution to use, and it requires just these 3-point estimates: the minimum, the best guess, and the maximum. So let's click on that. All right, so we see a distribution on the top. We see how relatively likely each value is across this range here. And on the bottom, we see the probability of being less than that particular value. So what's the probability of being less than 4? We can slide this guy over here, and we can read off some numbers on the table on the right. All right, so I want to pick the values from my spreadsheet. I go into the little control at the top left-hand corner. I select icon here, and I select the minimum distribution. Okay. Then I go to the next one. And the final one. And now you'll see the distribution is showing a range that starts at 105, which was our minimum cost, goes up to 130, our maximum, and it peaks. It has a most likely value of 110. So you see that the curve is maximum here at 110. Let's just insert that into the worksheet with a click. And what you will see now is a very strange number, 120.09. Where did that come from? Okay, well, what is entered into the spreadsheet is a function equals Vose, which is from our company, Vose Software, and then PERT, because that's a distribution we selected, and the 3 parameters. If I hit the F9 key, which is the spreadsheet recalculate, you'll see that this number changes. What's it doing? It's generating a random possible scenario. So for this purchase land item, it could be that it's $113,000. But if I keep hitting the F9 key, it could be 111, 115, etc. This is on the spreadsheet performing what we call a Monte Carlo simulation. All right. Why do we have these particular numbers? Well, if I just click on the view function, which you see here, because I'm in a cell that's got one of the XLRISK functions, by clicking view function, I can pull back up that view. And you can do this with almost any of the functions within XLRISK. If you're in that function, in a cell in that function, and you don't know what it means, all you have to do is click on the view function and some kind of visual interface will pop up, which will give you a good idea of what's going on. You can see that value 106. That's a value that's around here, somewhere around the most likely. You can see that the vertical axis is representing those values more likely to occur. We might occasionally get a value out here at 125, but it's relatively likely to occur, unlikely to occur. All right. Now, in a risk analysis model, what we typically do is we want to nominate variables in the model, uncertain variables, as inputs and others as outputs. I'll explain a little bit later how we come to use those. But this is clearly an input into our model. So we need to click on this output input icon and select mark output input. And here we have a little interface that allows us to say what we want to call it. Well, we're going to give it a name. Let's click on there and select purchase land. And then we can say what units we want to apply, and here the units are going to be thousands of dollars. So I'll just put K for thousands. Is it an output or an input? It's an input to our model. So I click on input, then click on OK. So we've put in a formula into this cell, And if I show you that formula on screen, you can see that it's using relative references. So B4, C, D, E4, they don't have any dollar signs on them, so they're not fixed. And that means that I can copy the formula down if I want to. So let's try and do that. I'll go copy, and then I'll go and paste the formula. And you'll see there's a problem down here, but let's come to that in a little minute. Now, you'll notice I haven't added copied the formula into the land purchase tax because this is exactly 5% of whatever the price of the land was. So we don't want to randomly sample something between 5.3 and 6.5 when we're taking a different sample for purchased land. We need this to be exactly 5%. So let's write that this is 5% of whatever the actual outcome land purchase price will be. So we write equals 5% times that value. All right. So I've copied the formula all the way down, but I've deliberately made a mistake. You can see here that the decoration costs, I've got a minimum of 11, a best guess of 13, and a maximum of 12. Well, that's not possible. If I was to go into here and delete the Vose input part, you will see what happens is that the function, the Vose pert function, actually returns an error, and that's a very, very useful tool. So instead of simply going hash value exclamation mark, your guess is as good as mine as why this isn't working, it doesn't do that. It tells you that the mode must be between the minimum and maximum, and it clearly is not. Now, if I was to change the number, then this will work. So if I made it 14, now everything's fine. All right, I'll just copy that formula down so we have it as an input as well. And we've almost finished completing the model. You'll see down here that we've summed the column of costs. And again, each one of these is a random scenario. So if I was to hit the F9 key, each time I do, we're generating a different scenario. Sometimes the land purchase might be a little less, sometimes the legal fees a little bit more, etc., etc. But in order to have a good idea of what the real total cost might be in the ranges, I don't want to just keep hitting this F9 key. That's not going to give me a good idea. What I want to do instead is see a distribution of what those total costs might look like. And to do that, I go into the XLRISK menu, I select outputs and inputs, and I'm now just going to mark an output. Right, so we give it a name, same idea. So total cost is the name. And we can use the units, and let's use K again. And it's an output, not an input, so I just click OK. And what you see now is that it's added not Vose input, but Vose output. And again, it has the reference to the label for what this thing is going to be called and the units. And I finished my model, so I can save this. And I can run the model. So what I need to do to run the model is decide how many different samples or different scenarios I want to generate. In general, you can just use about 3,000. So let's go in here in the settings. I'll change this to 3,000. That tends to be enough for most purposes. And then I'm going to run the model. You'll see on the bottom right-hand corner, it's showing the progress at 60, 70, 80, 90, 100%. And when it's finished, you'll see that there is a new window that opens, which is the results viewer. By the way, the XLRISK is one of the fastest simulators, if not the fastest simulator, of Monte Carlo simulations on the market. All right, so in this window here, where I've got the results, I can create any number of different graphs that I might find interesting. First of all, let's look at the left-hand side. We've got the list of all the different simulations. In this case, we only run one simulation, but we might have run several different options and repeated simulating the model to be able to compare which option is the best. We only have one output, which is the total cost, and we have a list of all these different inputs. So I'll just quickly kill all of these different graphs and start again. And I'll insert a histogram. And this is a histogram of the output, the total cost. And what do we see? We see that the total cost is realistically going to be around somewhere between $390,000, maybe up to $425,000. Most likely value is somewhere around 408 or so. Well, that's very interesting. Not only can we see the range and the most likely value, but we can also see the probability of being between or above or below different values. So for example, we can see here at roughly $400,000, it's a 5% chance it's going to be less than that. So you wouldn't want to be budgeting for $400,000. Similarly, $419,000, you've got a 95% chance it's going to be below that, so a 5% chance it's going to be above. That's probably a realistic amount to budget for. It would be interesting to be able to compare that against our original values. So let's have a look. You can see here that our minimum, when you added them together, all our minimum costs, we arrived at $370,000. Where does that sit? $370,000, in fact, sits way over here to the left. It's an absolutely impossible scenario. The reason for that is that all of those costs at the same time would have had to arrive at that minimum value. So that's tossing a coin hundreds of times, if you like, and expecting to get heads every single time. It's just not feasible. Similarly, it's not feasible that 462, pardon me, is the maximum. 462 is way over here to the right again. So we know that if we follow that more traditional way of just putting in the minimum cost, putting in the maximum, add them up, we're not going to get a realistic bounds. But surely if we add up the most likely values, then we do get a realistic number. Well, that was 404,000 here, but where does it sit? In fact, that's pretty optimistic. $404,000, which is around there. We only have about 28–30% chance that it's going to fall under that cost. And you might ask yourself, why? The main reason why is because these distributions are skewed to the right. They have a longer tail to the right than they do to the left. Or in other words, if you take one, for example, plastering, very typically, 28,000 is your most likely, but it could be 3,000 less, but it could be 5,000 more. So there's more chance of it being a higher value than this most likely than it is being lower value. In this very simple example, we can see how helpful quantitative risk analysis is in getting some realistic idea of how much your budget should really be. Now, we have a lot of other different graphs that we could choose, so let's add a new one. We can, for example, add a cumulative distribution. Now, the cumulative distribution is exactly the same information that is presented in histogram, but in a different form. So, for example, you can see there's a 5% chance of lying below about 400,000. That was the same number we had before. And 95% chance of lying below 420,000. Again, same numbers we had before. The vertical axis here represents the chances of being below that horizontal axis value. So you can move these sliders around, you can hit a particular target and ask yourself what's the chances of being below some specific number. So for example, if you were saying, all right, I'm going to budget 420,000, what's my chances of being below that? 96%, give or take. Well, that's pretty confident. So that would be a good number to take to the bank. Now, we also might ask ourselves, well, why is this cost so uncertain? What's driving the uncertainty in the cost? And for that, we can use a number of different graphs. But the best one to use is the tornado. So we'll add a tornado chart. What the tornado chart is doing is it's showing you how much, on average, the total cost of the project would be if your land purchase was at a very low value versus if your land purchase was at a very high value. That means that the length of this bar reflects how much uncertainty is being added into the total cost. And you can see from this graph that the purchase of land is by far the greatest driver of uncertainty in your total project cost estimate. We can also insert some statistics. So for example, let's do that here. Here we can see all of the different items, whether outputs or inputs. So first of all, we've got the total cost, and that's an output, and you've got all these others here are the inputs. And you can read off a bunch of statistics. They're the same statistics that you can read in a tornado chart, or you can read in any of the cumulative or histogram curves. At the same time, what we can do is we can go into the Home tab, and we can then go and create a report. So if you want to have a particular report in a PDF, then you can select Report, you can pick some variables you want to include, and you can send it off to Microsoft Excel, PowerPoint, Word, or PDF. So you have a hard copy, if you like. But what's very interesting about this particular results viewer is that you can also simply save the results. So if you save the results, you can then send the file off to a colleague who can open it, and they don't need to have the model. They can already view all the graphs that you've created, just as you're seeing them here, and they can even create new graphs themselves without having any extra need for modeling or other information. Everything that is needed is in that XLRISK results viewer file. This concludes a very simple example of how you can use XLRISK to perform a cost analysis. Bear in mind that this is just a simple example we're trying to offer because it's something that everybody can understand. But there are many, many applications of risk analysis. So I thank you very much for enduring this presentation. You are very welcome to ask questions and submit them through the conference, and I'm sure that we'll be happy to answer them. Specifically, I will be happy to answer them if they're very technical. Thank you for your time, and enjoy the rest of the conference.